Hello students, today I am going to discuss about the motion, very interesting chapter, motion. And this motion chapter, it is related with the first year course, so motion. So what is the meaning of motion? Motion basically it is when one object is moving from one place to another place, then we can say motion. So in this chapter basically you know what is the difference between the raised body and rigid body. First you see the name of the chapter is motion. Motion. So motion means what? What is the meaning of motion? Motion means when one object or particles is moving from one place to another place, then we can say there is a motion. So basically, if you just remember, there is a two terms. One is raised body, and another is a rigid body. So raised body and rigid body. So what is the meaning of raised body and rigid body? Suppose you consider raised body. Suppose one table is here, one table. So on the table, I consider one duster is here. This is a duster. So duster is at rest. This is the rest position. That is why duster will be known as rest position. Now, in case of rigid, I am considering this is a building. This is a building. Building also at rest. Here you can see this is a duster or this is a book is at rest, and here building is also at rest. Now, what is the difference between the raised body and rigid body? You remember, raised body means the body which is at rest, and also we can change the position. But rigid body, this is the rigid body. It is also in rest position, but we cannot change the position. We cannot change it. We can shift it from one place to other place. We cannot. Here you see building. This table we can shift from one place to another place, but building cannot be shifted from one place to another place. That is why this is called rigid body. This is called raised body. Now, in this chapter, I am just revision part I am doing. That means first I will discuss about the all formulas which are basically related with the numericals. So first you see, you should know about the displacement. In this chapter, displacement. First you should know about the displacement. So displacement. So what is the meaning of displacement? You just see one, this is one diagram, So a particle is going from A to B. So I consider A position and here B position. Now this particle is going from A to B. So after reaching B, you can see here this is a rest position, here also rest position. So now when the body is going, it is in motion. So you remember the initial point. This is called initial point. This is called initial point, and this part is a final point. So initial point and final point. So the object or body is traveling from A to B. There is a largest distance. This is called largest distance, and this part is a shortest distance. So you remember shortest path, and here largest path. So shortest path and largest path. You remember displacement means shortest path. You can see from the entire journey here the shortcut path will be A to B, but this distance means this part is the largest path, and this is also known as distance. So distance means largest path, and displacement means shortest path. That means shortest path. In case of shortcut, that means shortest path. That means we can write delta x is equal to x2 minus x1. This is the formula for displacement. Now see, this is the initial point. So initial point basically represented by x1, and final point it is represented by x2. So displacement will be delta x is equal to x2 minus x1. So this is the formula. So you remember there is a different types of distinguish between the displacement distance is given. So you just remember the formula, because these are the not important for you. So only formula is important. So displacement can be measured in meter. Now you can see distance. So distance means, you remember distance means distance means s. S means s1 plus s2 plus s3 plus sn. You remember this is called distance. That means this largest path traveled by an object, it is called distance. So distance, it is also measured with the help of meter. So displacement also measured with the help of meter. Now thing is that you remember distance and displacement never same, but under one condition distance and displacement will be same. What is the condition? Condition is when the motion node, so you can write node, that means displacement delta x is equal to distance will be same for straight line motion, straight line motion, straight line motion. So in case of straight line motion, distance and displacement will be same. Distance and displacement will same in case of straight line motion. Now thing is that in case of motion chapter, that means the name of the chapter is motion in a straight line. So there are different types of motion: straight line motion, circular motion, uniform circular motion, rotational motion, so projectile motion. So there are different types of motion, but second chapter of the book it is given a motion in a straight line. That means motion in a straight line. So in case of motion in a straight line, basically you remember first displacement. Displacement it is given. Displacement means it is the shortest path and distance is the largest path. So in case of shortest path, you remember delta x is equal to x2 minus x1. In case of largest path, you remember total distance s is equal to s1 plus s2 plus s3 like this. So this is the distance and displacement. Now see, suppose one example, I am considering one example, how we can calculate the distance and displacement from a given duration. Suppose one question. So distance and displacement, suppose question is there. Suppose motion of a car, suppose a car is moving from A to B. A car is moving from A to B. So initially, suppose here 0 kilometer in terms of kilometer distance, and here suppose I consider 50 and I consider 100 and I consider here 150 and here 200. So here I consider C and D point. Now see, motion of a car, it is represented by a straight line. That means car is moving in a straight line. In kilometer, it is given like this. So from the given diagram, we have to calculate the distance and displacement from, suppose we have to calculate, find the distance and displacement, find the distance and displacement. So find the distance and displacement, So how we can find the distance and displacement? From you remember from A to B, from suppose number 1 A to D, B number A to D, and A to B back to C again D. So two questions I have given here, you see. So how we can calculate the distance and displacement part? Now see solution. Here distance, first you see distance, basically it is represented by S. A to D. So A to D means 150 kilometer. So A to D means 150 kilometer. And this displacement also 150 kilometer, because I told you that distance and displacement is same in case of motion in a straight line. So now A number is over B number. You can see distance is equal to A to D. What is the distance? A to B. Distance 200 plus back to C, from here again back here. So here 200 minus, so it will be 100. Back to B again C, that means it will again D, that means it will be 50. So it will be 350 kilometer. So distance will be 350 kilometer, but you can see displacement, this is the formula, x2 minus x1. So in this case, you remember when we are going to find the displacement, here initial point, you can see initial point is A, final point is D. So what is the value of D, final point D? 150. 150 minus initial point is A. A means 0. A means 0. So 150 kilometer. So in this way we can easily calculate the value of distance and displacement from the given diagram. Now see, next distance and displacement is over. So next you see what is called velocity, speed. So first you see velocity. So first I will give the all formulas. After that I am going to discuss the numericals. So velocity. Velocity means, you remember, velocity basically V. Velocity means displacement by time. Displacement means delta x divided by time t. Okay, so we can write, this is the formula. And in case of speed, okay, first in case of speed, you remember, speed we can write distance by time. So distance basically as time is t. So this is the formula, you remember. This formula we can write V is equal to dx by dt, displacement by time, and this formula we can write V is equal to ds by dt. This is the velocity, so with respect to distance. Now you remember, this is the idea of velocity. Velocity basically displacement by time, and speed is equal to distance by time. So first you see, this is called velocity. Next you write down. Now average velocity. Next it will be average velocity. So what is the meaning of average velocity? So average velocity you remember, V average is equal to x2 minus x1 divided by t2 minus t1. So V average is equal to x2 minus x1 divided by t2 minus t1. That means here displacement, change in displacement, change in time. This is called average velocity. Now in case of average speed, you remember, we can write the formula V average is equal to total distance 3 Sn whole divided by t1 plus t2 plus this one, like this we can write. Or sometime we can also write V average is equal to E plus V divided by 2 also we can write. This is the average velocity. So this is the formula for average velocity. Now you can see, next, this is the velocity and this is the average velocity. Now acceleration we can write here, acceleration. Acceleration means, you remember, double derivative of displacement. So that means acceleration E is equal to dv by dt. We can write A is equal to double derivative d square x divided by dt square. Acceleration. So in case of retardation, that means deceleration, A is equal to minus dv by dt, and here A is equal to minus d square x divided by dt square. So this is acceleration and this is retardation. So acceleration basically double derivative of displacement, double derivative of velocity, and double derivative of velocity or double derivative of displacement. This is called acceleration. So retardation means negative acceleration. It is called retardation. You can see here minus symbol is given. So this minus symbol represents retardation. Now acceleration basically it is represented by unit is meter per second square, and here also meter per second square. Now average acceleration. What is the meaning of average acceleration? So average acceleration means, you remember, A average is equal to B2 minus B1 divided by T2 minus T1. So average acceleration is equal to V2 minus V1 divided by T2 minus T1. This is the average acceleration. This is the average acceleration. So this is the idea of the mathematical formula of velocity, displacement, acceleration. Now there is some formula related with the motion. This is called equation of motion. Equation of motion. So equation of motion or kinematic equation. So equation of motion. Equation of motion. So in case of equation of motion, you remember there are 4 types of formula is given. So in class 9 you got only 3 formula, but in class 11 you got 4 formula. That means V is equal to U plus AT. Number 2, S is equal to UT plus half AT square. Number 3, V square is equal to U square plus 2AS. Number 4, here Sn is equal to U plus A by 2 twice n minus 1. So these are the formula, and physical meaning of the formula already you know. Here you can see where you can write where U means initial velocity. Initial velocity means meter per second. And B means here final velocity. Final velocity means meter per second. And A means acceleration. Actually it is equal to meter per second square. And here S means distance. Distance means meter. So here you can see L means number. Now these are the basically physical significance of the given formula. V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS, Sn is equal to U plus A by 2 twice n minus 1. Now see, first this is the formula. So these 3 formula you remember. So this formula it is valid. Now see, this formula it is valid when the particle is moving horizontal direction. We can write like this. Basically 3 formula. You remember, you can write as a note like this. That means when a particle is traveling from one place to another place in horizontal direction, then we can say these are the formula is applicable. Now we can write like this. Number 1. Number 2, V is equal to U plus ZT, S is equal to UT plus half ZT square, and V square is equal to U square plus 2ZS. So in this case, you remember these 3 formula, that means Z, instead of A I have written Z. Z means acceleration due to gravity. And here normal acceleration, this is a acceleration due to gravity. That means this formula is valid when any particle is coming down. That means vertically downward, then we can say V is equal to U plus ZT, S is equal to UT plus half ZT square, V square is equal to U square plus 2GS. So one thing you remember, when we are talking about the height, so height means S is equal to, we can consider H. So instead of S, we can write H. Now see number 3, this formula V is equal to U minus ZT, S is equal to UT minus half ZT square, V square is equal to U square minus 2ZH. So this formula is valid when the particle is moving up. So you remember these 3 formula, number 1, number 2, number 3. Depending upon the questions, we can use 3 types of formula. If it is the particle is moving upward, then we have to use this formula. If the particle is going down, this formula. If the particle is moving horizontal direction, then we can use this formula. This is the idea. Now see, Now see numericals related with this formula, and there is a one relative velocity also there. So first you write down relative velocity formula. Relative velocity. Relative velocity also in C syllabus. Relative velocity means you can see, suppose one particle A is going, suppose A is a particle, velocity is VA, and another B particle's velocity VB. So relative velocity means BAB is equal to BA minus BB. Similarly, if I am writing BA, that means BB minus BA. So in this case, BAB is equal to BA minus BB, BBA is equal to BB minus BA. This is the formula. So in this case, you remember, this is a relative velocity. This is a relative velocity. That means relative velocity we can write in this way when both the particles moving along same direction. So this is the condition. This is the condition for this. Now this is A number, and B number you can see, suppose one particle is going this direction, that means A is here and BA like this, and another particle is coming back like this, so B particle here, so it will be BB. So therefore relative velocity will be BAB is equal to you can see BA minus BB. But when we are writing BA, that means here minus sign will be here, minus, because this particle is going like this. So minus B minus A. This is the formula. So relative velocity. So what is the meaning for that? So here you remember BAB, that means relative velocity of A with respect to B. What is the meaning? Meaning of BAB, meaning of, that means relative velocity of A with respect to B here. Now in this case you can see relative velocity of B with respect to A, you remember. And here velocity BA means velocity of A, and BB means velocity of B. You remember. So this is the idea of relative velocity. Now I am going to discuss the numericals. First you see, suppose how we can calculate the distance and displacement from a given graph. So suppose you have given distance and displacement graph, we are going to find the distance and displacement from a velocity time graph. So one question is given to you. Suppose this is a diagram. So find the distance and displacement from the given velocity time graph. From the given velocity time graph. Find the distance and displacement from the given velocity time graph. So this is a graph, it is given to you. Suppose this is a graph. So in this graph you can see, suppose here 0 position, here 2, 4, 6, 8 like this, and here 2, 4, 6 and here 8. So this value will be negative, -2, -4, -6, -8. Now see, the graph is like this up to 6. Again you can see it will come 8 like this. like this. We can consider in this way. Now see, here I consider here suppose 5, here 10, here 15, here 20, here 25, here 30. So now see, this is velocity and here this is your time. This is your time. So velocity time graph is given. So from the given graph, we have to calculate the value of distance and displacement. So very simple, you remember solution. So first you see distance. Distance means S. S means distance means S. S means area under graph, area under curve. So area of this is a kind of triangle. So area of this area half into base. Base means 5 and height it is 6. Next you can see this is a kind of rectangle plus, in case of rectangle you can see here length into breadth. Length means 1, 2, 3. So that is 20 minus 5 you can write here 15. Multiply, it is going down. So here up to 8. So length into breadth. Length means 15 because from 5 to 10 1 unit, 10 to 5 1 unit, 15 to 20 1 unit, and each unit value is your 5. So it will be 15 and here you can see downward it is 8. Next plus this is a kind of triangle. So this triangle we can write half into base. Base means here 10. Height means here 4. Height means 4. So now displacement delta x is equal to, same thing will come, you remember here it will come like this, half into 5 into 6 plus 15, here only it will come minus 8 plus half into 10 into 4. Now you can see the result is 2, it will be 3, so it will be 15 plus 15 into 8, 120, and here 2, it will be 20. So 140, 15 is equal to 155 meters. Again you can see here 2, it will be 3, so it will be 50 plus minus, it will be minus 120 plus 2 to 5, 20. So here you can see minus 120 plus 35. So you will get here 120, so 120 and here 35, so 5, it will be 10, 5 and 11 and 8, 85. So 85 meters. 85 meters. So that is why minus 85 meters. So you remember in case of distance you can see I told you that distance is the largest path traveled by an object and displacement is the shortest path traveled by an object. That is why distance will be 155 meter and displacement will be minus 85 meter. You remember, this is in this process we can easily find the value of distance and displacement. Now next you can see from displacement how we can calculate the velocity acceleration like this. Suppose you have given question